Okay, our next topic is hazardous waste. Now, how do you define hazardous waste? As I mentioned, all hazardous waste are solid waste, but not all solid waste are hazardous waste. As defined by US EPA, hazardous waste refer to the waste that requires special precautions in storage, collection, transportation, treatment, or disposal to prevent damage to persons or property, and includes explosive, flammable, volatile, radioactive, toxic, and pathological waste. Okay, for hazardous waste, in order for you to classify as solid waste as hazardous, these are some of the characteristics of the waste. So aside from the four major, which is toxicity, ignitability, corrosivity, and reactivity, we can also add being radioactive and being infectious as classification of hazardous waste. Although you can already classify radioactivity with reactivity and infectious under toxicity. Now, this table, which I got from your reference book, would tell you or would guide you how to classify whether the solid waste is hazardous or not. So in your LCA, in your case study, you have to identify the solid waste that would be generated by the process or within the process, and then after identifying the solid waste, you are further required to identify whether it is or classify whether it is hazardous or not. Now, how do you do that? This table can guide you. Okay. So, since we don't have a power plant in the Philippines yet, you might be working in other countries which utilize nuclear power plant. Let's try to discuss nuclear waste and how to manage them. Now, for refinery and fuel fabrication waste, there are no significant wastes since uranium is being recycled. Then, for what is the major waste coming from the nuclear power plant is the spent fuel, as I have highlighted a while ago. So what is spent fuel? Your spent fuel is the casing wherein they put the uranium ore. So I have here an example of the casing, this one. So they put the uranium ore inside this rod. Now the moment the uranium rod is already utilized and have been converted to energy, this now becomes empty, and this is what you call a spent fuel rod. So your spent fuel rod is the major problem of nuclear power plant. So when it is discharged from lightweight reactors, these now contain some traces of uranium, plutonium, and fission products. Because a nuclear power plant has a nuclear fission as a process. Now, how do you envision how a nuclear fission occurs? You have the main radioactive or the mother radioactive material, and then this, you have just to bombard it, let's say, with an alpha particle or any nuclide. Then this will further go to produce daughter radioactive materials until such time that you produce the most stable compound. Still, the most stable compound of a nuclear fission is classified as toxic, which is lead. So, these are some of the possible contamination for the rod that we have mentioned. So, we call it spent fuel. This cycle would tell you further what are other nuclear waste that may be generated. So as mentioned, the uranium tailings will be recycled, so technically there are no waste. But still, if you're running the nuclear power plant, you have to ensure that all of these uranium tailings will be recycled. Otherwise, that will be added to the nuclear waste or the waste, hazardous waste that will be generated from the plant. Aside from that, we mentioned about the spent fuel rod. Although from the cycle, you can see that we can also recycle the spent fuel rod. How? Take a look at this part. The spent fuel rod, because of its energy, the energy being released from nuclear fission, which is tremendous. You have that idea already. That means the fuel rod are so hot, and therefore you need to immerse it first to a basin of water, as you can see here. Now I have a more detailed picture here of how do they make the spent fuel rod cool. So you see the big basin, so this is composed of water, and then they immerse here the spent fuel rod. So our next concern with respect to the environment is, where do they dispose the wastewater? And how do you treat the wastewater contaminated with the radioactive materials? So that's the next concern of the power plants. Next thing is, although as I have mentioned, you can recycle the spent fuel rod based from this cycle of nuclear power plants. Upon recycling once, twice, thrice, there's no such thing as forever recycling of a product, because definitely it would affect the quality of your product. So what will happen is that after some time, your spent fuel rod would no longer be recycled. So what do? You have to make sure that these have to be treated prior to disposal. Please take note, class, that your spent fuel rod is contaminated with several nuclear or radioactive materials, as we have mentioned. Now, in order to contain such problem, what is being done is they are encapsulating this nuclear spent fuel rod with glass. So the process is called vitrification. So when the glass is used to immobilize your spent fuel rod under the process of vitrification, and it has been ensured that the radiation has been immobilized, that's the time they send these immobilized spent fuel rods into a special sanitary landfill. So it's not the same sanitary landfill that you have seen in your plant visit, but it's for a nuclear power plant, it's a specialized sanitary landfill. Because remember how contaminated are the fuel rods. Other health and environmental effects of nuclear waste would include the low-level waste. Where do you get the low-level waste? So these can be generated from uranium mining and uranium operations, which release small amounts of the following radioactive materials. Now, take note, class, that radium has an oxidation number of +2, right? And therefore, these could also have the same effect as lead +2, which could affect your calcium in the body. And therefore, as we have discussed, since they have the same oxidation number, they can replace, or the radioactive materials can replace the calcium in your body, and therefore may affect bone destruction, and then eventually, if it already reaches your bone marrow, may cause weakening of your blood, or what we call leukemia, anemia, and then further it can cause leukemia. So radium-226, ingestion of which would result to blood and bone disorders, as mentioned, while Ra-222 can cause cancer to uranium miners. How about high-level waste? Wastes are produced in relatively small volume in the reactor fuel core, where in a short time, the fresh fuel becomes intensely radioactive. So this may be lethal when cooling of the fuel in the reactor is interrupted. So at this part, the high-level waste can be mitigated, unlike the low-level waste. Now, normally, in operating nuclear plants, once the nuclear fuel has reached the end of its irradiation period, after 1 to 2 years, it is removed so that fresh fuel can be inserted. This is where the problem on how to dispose and how to treat first your spent fuel rod may be a problem. It is highly radioactive when you try to dispose it because it contains some of the fission products and transuranic elements that we have discussed. Now, it has been found out also that overexposure of workers can damage their human tissues. That's why they have this hazard pay. So for those who are working in the nuclear power plant, they have this hazard pay. Now, since we have mentioned that the tailings can be recycled, so the tailings should be returned where it was extracted, but if only 30 to 40% may be returned, still this may be causing the low-level waste that would cause the specific impacts that we have discussed. So what are we doing is that most uranium mining companies plan their operations so as to dispose of tailings in carefully engineered surface facilities. So it is specifically and specialized for nuclear power plants. Now, what are some of the toxic metal contaminants that you can get aside from those transuranic elements? So you may also have arsenic, cadmium, mercury, molybdenum, vanadium, zinc, together with iron. And these inorganic contaminants may also have some negative ions when they are present, they may also give off some impacts. Now, radioactive contamination may also be brought about by the uranium tailings itself, especially when it is not handled properly. Now, other environmental concerns may come from the isotopes of uranium such as thorium, radium, and radon as radioactive daughters. Okay. Now, they tried, I've read from the book that they tried to have these uranium tailings to be fillers for buildings because they thought that the small amounts of this may not affect anyone. But what they have learned is that these fillers have caused cancer to the inhabitants of the buildings which are made up of these fillers. So this happened in 1980s in US, and thus they have declared that these nuclear uranium tailings must be handled properly. This is the one that I mentioned. So about 10,000 lung cancer fatalities per year was found in US because of the utilization of the uranium tailings from the power plants. Another type of hazardous waste are called biomedical waste. These refer to cultures and stocks of infectious agents, or this may also include human pathological waste coming from hospitals, human blood and blood products, and even the sharp elements, whether used or unused, as well as contaminated animal waste, probably from veterinary hospitals. And these may also come from isolated waste from patients with highly communicable diseases. Now, basically, biomedical waste could be treated by sterilization. However, they have found out that because some of these infectious materials or biomedical waste may mutate, therefore, you need not just sterilize it but further treat it. Example of further treatment is, as I mentioned, incineration. So there are some misconceptions in RA 8749 or Clean Air Act that incineration per se is already banned. But you have to read the provision that the incineration is still applicable for biomedical waste. However, as we have discussed a while ago, the incineration has to be engineered properly. together with proper water walls to control the temperature as well as collection of ashes. Okay. Now, if the hospital would just be treating a normal biomedical waste, still they do sterilization prior to handling. Because without the sterilization, the transfer of the microorganisms may be possible. Now, in order to do that, prior to sterilization, they still have to do proper bagging or labeling of the materials. So when you go to hospitals, you could see their trash bins with specific colors. Now, you have to follow that because they strictly follow that as they transfer it, the bin, to the holder and then to the treater. As a matter of fact, hazardous waste have to be placed in a manifesto or in a list which is being checked from the source to the transporter to the treater, which we will discuss in the hazardous waste paradigm later. So, with lacking incineration and sterilization, waste are segregated and packaged in specialized color-coded and labeled containers. Again, let me reiterate, before these parts is being practiced. So you just have to label it and then put it in a properly colored labeled bags and then you can dispose it. But now no more. There is a strict implementation of RA 6969 or hazardous waste on biomedical waste, probably because of the spreading diseases that we are having right now. So incineration is really one of the best way to treat your biomedical waste. Now, our next hazardous waste are the chemical waste, examples of which would be TV sets, heat pacers, earth satellites, aerosol cans, pesticides, spectrum of plastic materials. So what do you notice? These are big and huge solid waste materials that because of their composition, they are classified as hazardous waste. Now, you may also have small ones such as, I'll give you an example. In industry, the most common problem are the containers of solvents as well as containers of paints. If you have a container of paint with hardened paint, that is already classified as hazardous waste. So what do they do? If you're the one handling the waste, how would you make that hazardous waste into solid waste? Your objective class when you'll be an engineer in a plant is to shorten the list of hazardous waste. Why? Because that's not sustainable if you have a long list of hazardous waste. So again, your aim is to make it shorter. Now for example, with respect to the container with the hardened paint, how would you make it an ordinary solid waste? You have to, normally in industry, what they do is they spray the hardened paint and then they just contain the hardened paint separately from the container. Now, if you do so, the empty container of the paint is already classified as a solid waste. Follow? So what you will just have to immobilize are the sprayed hardened paint, not the entire pail or container of hardened cement. Okay? Now, in most industries also, they have MRF specifically for hazardous waste. Because, as I mentioned, they have to follow the hazardous waste paradigm. The hazardous waste paradigm, which would start from waste generators, these are actually the industry sources. Then you will have waste transporters. Then you have to have waste treaters and recyclers. Now, how would we explain the paradigm? The waste generators are the industries. So you're the one to generate the manifesto. Now, these generators cannot have their on-site hazardous waste treatment. Why do you think so? Because it's not sustainable. Unlike wastewater treatment plant, which is sustainable, you need to have more capital investment if you have an on-site hazardous waste treatment plant. Aside from the fact that if you have a hazardous waste treatment plant should secure an ECC because it will be classified as another industry. So for that reason, and to have or to maintain sustainability, most industries would just hire a treater for them to treat their waste. However, the problem with that is the transport of the hazardous waste, right? Which will be more prone to contamination. In order to do that, you have to follow the rules on the hazardous waste paradigm. So number one, as I mentioned, the generator should have a manifesto, a list of hazardous waste. Again, what's our rule of thumb? You have to make it as short as possible so as to make sure that it is properly monitored. Now, what will I do if I am the industry waste generator? I need to find a certified and accredited waste transporter in which its job or role is just to transport the hazardous waste from the point of source to the point of treatment. And another body within the paradigm, which are the waste treaters or waste recyclers, would be accepting the waste. Okay? Now, the waste treater, aside from the ECC or the Environmental Compliance Certificate, need also to maintain or to make sure that they have the same manifesto as that of originated from the waste generator. Now, this is also a growing industry, the waste transporter, because the waste transporter, because of the risk, need to ensure that there will be no contamination along the transport. I think you have heard about trucks along the highways which just flipped because of accident. Now, if you're a transporter and that accident would occur, you have to pay for the damage. Aside from the damages, you have to pay for the cleanup of the area. And you have to ensure that there will be no contamination, no risk that will be posted on the environment where it is spilled, as well as on human impacts brought about by your cargo.